Hello, friends, welcome back to the channel. And if you are new, then welcome to the channel. In this video, we are going to. Oh, oops, I'm on the last slide. Okay, so in this video, we are going to learn about version space and the candidate elimination algorithm. What it is now. This is the next topic after find S algorithm. In this, we are going to learn another algorithm how we can make our hypothesis more general or more specific. So we will see that in next few slides. So yeah, let's learn this topic. And if you haven't subscribed till now, then please first do that. And so let's continue. What is version space? First, I need to teach you what is version space. Otherwise, you will not understand anything. I'll teach you what the words mean in this. Otherwise, you will not understand anything in the entire explanation. So, I'll explain you first what is version space. Then, I'll explain you what is hypothesis. Then, I'll explain you what are examples. So, yeah, let's see. What is version space? Imagine you are teaching a computer to recognize cats. You start with many ideas of what a cat might look like. The idea are like guesses or these are called hypotheses. Now you show the computer pictures of cats and not cats. If a hypothesis correctly classifies a cat, it stays. If not, it throws. As you show more pictures, some wrong guesses get thrown out and the computer's guess get more better. The space of remaining guesses is called version space. So, you understood it? No? Then I am here to explain you. First, consider you are teaching a small child to recognize what cat might look like. The child have never saw what is cat and how it looks like. So now you are giving some guesses in the air that the cat has a tail, it has some 3 4 mustaches, the hair, and it has horrible eyes, and few cats are cute also. And it has hairs like how dogs have on their body, and you give such kind of guesses to the child, and after that you show the child the pictures of the cat, different pictures of different cats. Now the child will recognize all the cats, and if the child is unable to recognize the cat, that hey, you teached me this but this doesn't look like cat, so it will throw that it will throw that hypothesis, and that hypothesis will be out of its data, out of its mind. It will not consider that hypothesis. So as I gave more images to the child of the cats, it will recognize the cats more better, right? And it will throw out all the guesses which are irrelevant. So the remaining guesses which are there with the child, that is called version space. I hope you understood it. If it is more complicated, then please rewatch this video. I'll move forward. The goal is to narrow down this space of guesses to just one, the perfect idea of a cat. But sometimes it's okay to have few guesses left because some cats might look a bit different. So, version space is like a list of guesses or hypotheses, and we are trying to find the best guess by showing the computer lots of examples. That means I am showing lots of images of the cats to the child, and the child is recognizing the images of the cats, and its guesses, its recognizing power is becoming more better and better. So that is version space. Now, the candidate elimination algorithm incrementally builds the version space given a hypothesis space H and set E of examples. Here, the candidate elimination algorithm works with space, I mean hypothesis space H and a set of examples given. Now, using this hypothesis and set of examples, it builds the version space. That means we gave the assumption, we gave the guesses in the starting to the child that the cat might look like this. After that, we gave set of examples. We showed the images of different cats, that is examples. And it built the version space. That means it started becoming better and better in recognizing what cat might look like. And finally, it will be able to recognize a real cat in real world. So that is what candidate elimination algorithm works for. The examples are added one by one. Each example possibly shrinks the version space by removing the hypotheses that are inconsistent with the example. The candidate elimination algorithm does this by updating the general and specific boundary for each new example. I know that you will not understand these statements now, but read it 2 3 times carefully. Until then, I'll explain you the further things. What is hypothesis? And examples. Hypothesis. This represents the set of all possible hypotheses, concepts, or guesses that our machine learning model can consider. Each hypothesis is combination of attribute values. And what is set of examples? These are training examples that our algorithm uses to learn. Each example consists of input features and a known output, positive or negative. The output may be positive or negative. As I shown you in previous videos, that examples might look like this, and if the output is positive, the example is positive, and if the output is negative, the example is negative. So that is set of examples. Now let's go forward. Terms used in version space and candidate elimination algorithm. Concept learning. Concept learning is basically the learning task of the machine learned by trained data. This concept learning is detailedly explained in previous videos. If you haven't watched those videos, please watch that and then come to this video, because you will not understand anything over here. Wait. If you are understanding, then it's okay. If you are not understanding, then please watch previous videos. The next is general hypothesis, not specifying features to learn the machine. And general hypothesis, as we saw in previous video, question marks includes all the data. That means this one attribute will accept all the values. So that is number of attributes. Now, specific hypothesis, specifying features to learn machine. Specific features. S is equals to star, that is attributes. The number of star depends on number of attributes. So, general means we are giving, we are accepting all values in one attribute. And specific means we are accepting only specific value in one attribute. And the number of attribute, it depends. Now, next is version space. It is an intermediate of general hypothesis and specific hypothesis. It not only just writes on hypothesis, but a set of all possible hypotheses based on training data set. So this version space is like it lies between general and specific hypothesis. It is not, we cannot say that version space is, it contains only general hypothesis or it contains only specific hypothesis. It is intermediate of both of these hypotheses. So let's go further. Now let's explore version space and candidate elimination algorithm with some simple example to illustrate how they work. Scenario: suppose we are trying to teach a machine learning model to recognize different types of fruits based on their color and shape. We have two attributes, color and shape. The color may be red, yellow, or green. The shape may be round or oval. So let's see the examples. Here, the data is given, and we are feeding this data to the machine learning model. And according to the candidate elimination algorithm, it will give some hypothesis to us, and that we will understand further. First, let's see what is the data. First, we have round, red, and sweet, that is apple's features. Then we have watermelon, which is green, round, and sweet. And we have cucumber, which is the shape is green, the the color is green, the shape is oval, and it tastes slightly sweet. The tomato, you know, all these fruits and vegetables, I know. So this data is given to the machine learning model, and we are trying to get the hypothesis for recognizing a fruit. And here, as you see, cucumber is not a fruit, it is a vegetable. And yeah, that's it. So we want to build a model that can classify fruits as accurately as possible. Here is how version space and the candidate elimination works in this scenario. So let's see how it works. So here I have opened my Microsoft whiteboard, and I have pasted the image from the slide of the data that we are feeding to our machine learning model. And according to the candidate elimination algorithm, we are going to derive the final hypothesis. So how it works? First of all, initialing we will initialize the most specific hypothesis and most general hypothesis. And the specific hypothesis is initialized by null, that means it is not accepting any values, and general hypothesis is initialized with question marks in its attributes because it is accepting all the values. Now we are covering now the first example. First example is of apple, and it is a positive example. So as it is a positive example, we are going to only work with specific hypothesis. We are not going to touch the general hypothesis. So we will change all the nulls to be specific. We will change all null with the values which are in the example: red, round, and sweet. Now what we will do is we will keep the general hypothesis as same as it was. Now what we will do is we will consider the second example of watermelon. The color is green, shape is round, and taste is sweet. And it is a positive example. As it is a positive example, we will only work with specific hypothesis, not with general hypothesis. Now what we will do is we will compare the previous hypothesis and the current example, and according to that we will put question marks if there is a difference between both of the attributes, and if there is no change we will keep it as it is. So as we see, here the first attribute is red and the second attribute is green. So I have put a question mark over here. And the second attribute is round, and the second attribute is round, so I have put round as it is. The third attribute is sweet, and the third attribute is sweet, so I have kept sweet as it is. Now what about general attribute? We- Now what about general hypothesis? We will keep it as it is. Now we will work with third example, which is a negative example. So now for negative example, we want our specific hypothesis to be specific. We are not going to change our specific hypothesis. We are only going to work with general hypothesis. So what we will do is it will remain same, and for general hypothesis, please listen carefully. As here the first attribute is green in this example, we will consider all opposite values of color, and we will take this over here like this, as here the opposite colors are only red of the green. Opposite color of green are only red, so I have kept red over here. And for remaining attributes I have kept question marks. Please listen carefully. Now the second one, for second attribute, what are the all other opposite shapes? Only round, isn't it? So I have kept the first attribute as question mark, second attribute as round, which is opposite of oval, and third attribute as question mark. Now, what I will do is I will compare the third attribute with all the possible opposite values. So, here we have sweet, we have sour. So, I have kept question mark, and sweet, which is opposite of lightly sweet. And I have kept sour, question mark, and sour, which is opposite of lightly sweet. So, check if all are consistent or not. Now, we are going to check if all of them are consistent or not. What does consistent means? Now you will understand by comparing all this. First, we will take this. Now, we will compare it with the examples until which we have came. So until what example we have came? Until third example we have came. So we will compare this until third example. So red, question mark, and question mark. Question mark includes all values. Okay, so red, compare with first example. Red, same. Question mark includes round, includes all shapes, right? Includes round and includes oval. So includes both of them. Question mark includes, again the third attribute. Question mark includes all, sweet, lightly sweet, and sour. So it includes all. So matches with the first example. And the first example is positive example. So it is consistent with the first example. So if if this is matching with the example and the example is positive example, now we will compare it with the next example. Red, question mark, and question mark. Here we have green, so it is not matching with the second example, but we are expecting this to match with this, but it is not matching. So what we will do, we will remove it. We will remove it from the general hypothesis. So this gets removed, this one gets removed from the general hypothesis. Now for the second one, question mark, round, and question mark. Question mark, round, and question mark matches with the first example. How? Question mark includes all colors, red, green, all. Now round, matched. Question mark includes all tastes. So it matched, and it is a positive example. So we will keep as it is and we will match it with the second example. We have question mark, round, and question mark. Question mark, it covers all examples. Round covers all examples. Sorry, round get matched. Question mark covers all example and it is a positive example. So we will keep it as it is. We will not remove it from the general hypothesis. Now we will compare it with the third example. Third example with question mark, round, and question mark. So question mark all covered, round. Here this is oval. It is not matching. But what it is a negative example. So it is consistent, because as it is not matching and this is a negative example, we don't want this to match, right? So we will keep it as it is in the general hypothesis. Now we will compare it. Now we will compare this with all these examples. Question mark, sweet. This matches the first example. And again, second example, question mark covers all, question mark covers all, sweet, matched. Now the third example, Question mark covers all, oval covers all, sweet. It is not sweet, but it is a negative example, so it is consistent. So we will keep it in this general hypothesis. Now, the last one, which is question mark, and soar. So we will compare it with the first example only. Here only we can see that it is not matching with sweet, and it is a positive hypothesis. So it is not consistent. Now we will remove it from the general hypothesis. So until now, what examples are remaining with us? This question mark, round, and question mark, and this question mark, and sweet. These both are remaining with us in the general hypothesis. So we have both of them in G3. Now, fourth example, red, round, sour for tomato, and it is a positive example. As we are moving from negative to positive example, first though we will work with this specific hypothesis. We will compare all the attributes, and if the attributes are not equal, we will replace with question mark. So here I have this fourth one and this S3. We are going to match both of them. So uh, as red and question mark covers all of them, so we will keep it as it is. Round and round, so both are matching, we will keep it as it is. Sour and sweet, both are different, so we will replace it with a question mark. So specific step done. Now what about general? We will compare both of this with the current example. How we will compare? See, question mark, round, and question mark. This matches red, round, and sour. How? Question mark contains all, round is same, and sour also contains all tastes. So it matches this. Fourth example. And the next one is question mark, and sweet. Question mark contains all colors, and question mark contains all shapes. But sweet, it is sour, not matching. So we will remove it from our general hypothesis. Now we are moving to the next step, which is positive. So we will work with this specific hypothesis only. So what will happen to the specific hypothesis over here? Here nothing will change because we are comparing this fifth one with S4. So question mark is containing all colors, round is same, and question mark is containing all tastes, so it will remain same. And here in the last step, this general specific will also remain the same, and we are not going to do anything with general hypothesis. So this is what we have received after all these steps, and this is the final general and specific hypothesis for the given data. I will cover more examples in next videos. I understand this is complicated. If you don't understand this, then please just go back where you didn't understand anything, or just watch this video again. I hope you will understand it. And yeah, don't take pressure, you will understand it slowly slowly. And uh, should I give a review? Okay, I'll give a review. So initially we initialized both of them. For positive we are going to work with specific, and general will remain same. Again for positive we are going to work with specific, general will remain same. Now for the third example we encounter, it is a negative example. We will keep this as it is, and we will generate a different kind of this hypothesis for general hypothesis, and we will compare all this with the examples until 3 that we have worked with. So we will compare all of them one by one with all of these examples, and we will see which of them are consistent. So finally we got two hypotheses which are consistent. And from we are moving from negative to positive, from 3 to 4. So we will compare this. So this examples, I mean this hypothesis attributes matches with four examples, so we retained it. And this hypothesis attributes didn't match, so we removed it. And after that we again got positive example. So there is nothing to change in S5 from this to this. After comparing also we saw that nothing is there to change. And the general hypothesis will remain same as it is. So this is what we have received after performing all these steps, and I hope you understand this. If you don't understand, please rewatch the video. And yeah, that's it for this video, and I'll see you in next video with another example. Until then, thanks for watching and subscribe to the channel for more such videos. And yeah, thanks for watching. Bye bye. And whatever opposite values